Okay, so there was no video module for section 8.2. Instead, we're going to take some notes here and talk about how we find surface area and volume of different three-dimensional solids. So let's start with surface area. Let's give it a nice little definition, and then we'll look at some examples of how we calculate surface area. So first thing I'm going to say is that surface area as an idea is the sum of all the areas, and we know how to calculate areas of two-dimensional figures from last class. So this is going to be the sum of all areas of all exposed surfaces. Right, and then as for the process, of how we compute surface area, we're going to separate each face. We're going to separate each face of a figure. Then we're going to find the area of each face. And then we will add all of these areas together. And the simplest example that of a three-dimensional figure that we can do is a prism, is a rectangular prism. So let's do that example first. So we'll draw our rectangular prism, and we'll give it some side lengths. We'll say the height is 10 inches, the depth is 4 inches, and the width is also 4 inches. So in this case, it's not just a rectangular prism. This is what we call a square prism, because the two bases down here and up at the top, those two bases are squares. So find surface area. I guess that's the question that's going to be for all of these examples. So I'll write that once, find the surface area, and then we'll do an example where we have a square prism. Now, first step in the process is to separate each face of a figure. So we're going to count how many faces this has, and we're going to write down a breakdown of the faces that we're seeing. First of all, a prism, a square prism like this will have 6 faces. There's the front face, the back face, the 2 side faces, and then the top and the bottom, which we will call bases because they are identical and connected with rectangles. So when I break this apart into its multiple faces, I will actually draw the faces. I'll say there's a rectangle. Sorry, there's multiple of these rectangles, but there are these 10-inch by 4-inch rectangles. And how many of these rectangles are there? in the whole figure. There are 4. Good. I'm going to put a times 4 next to that one. And then the other type of face that this figure has is a square. Right, a 4-inch by 4-inch square. And this is where we see the top and the bottom face, and there are only 2 of those. All right, so now that I've accounted for all 6 faces and I've drawn out what they look like, the next step in the process is to find the area of each face. So I'm going to go through and I'm going to find the area of these rectangular pieces, which will be, as we learned last time, it'll be length times width. So it'll be 10 times 4, which is 40 square inches. And the area of the square is going to be, again, length times width, which is 4 times 4, which is 16 square inches. Once we have the area of each of these faces, we need to account for how many of each face there are. So we're going to take the, so we're going to say total area of, the total surface area of the rectangular prism is going to be this 40 times 4, because there are 4 of those faces, plus the 16 times 2, because there are 2 of those faces. All right, so I multiply the area of each face times how many of these faces there are, and then we add the result together because that was the last step of the process. And this results in 192 square inches. So once we multiply by how many of each face there are, multiply how many of each face there are by the area of each face, and then we add all the results together, we get our total surface area for the shape. So that's what we do in general. I'm going to give you a couple of specific shapes that are a little bit trickier so that you know how to deal with them. But before I do that, are there any questions on this example or the process? Okay, if you have any questions while I'm talking, just feel free to put them in the chat as I'm going through this. What I want to make a note of is the 2 different shapes that I want to talk about. So I do want to talk about cylinders. So we have a cylinder is it's essentially a prism, but the bases are circles. So we have sides, we have the vertical sides, we have the, well, it looks weird. Okay, that's what a cylinder looks like. Usually there are 2 dimensions associated with the cylinder. It's the height, which is, I'll call 9 inches, and then there's the radius of the circle part that is on top of and the bottom of the cylinder. We'll call that 5 inches. So we have radius for the circle and then a height for the prism. And when I break this apart into its surfaces. You may have seen this before, but when I break this apart into its surfaces, we have those discs that are at the top and the bottom. So we have those circles where the radius is 5 inches. And there are 2 of those. Because there's one on top and there's one on the bottom. And what kind of surface, do you know what kind of surface that's, the surface that's combining the bases is? What kind of shape is that? Anyone know? It's kind of like a toilet paper roll shape. But no, Aaron, you're right. If I were to cut that toilet paper roll along, just cut that toilet paper roll through and open it up and spread it out, you would see that we have actually a rectangle that's essentially wrapped around to make that cylinder, right? So we have a rectangle there, and the sides of the rectangle are interesting because this vertical side, this side here, is the same as what I cut along, which is the height of the cylinder, which is 9 inches. So that part is just from the figure. But the other side of the rectangle is interesting because when I cut along here and I unwrap this top distance of this rectangle here is the part that kind of wraps around on itself. So that's this distance here in the three-dimensional figure, right? It needs to wrap around that disc. So the distance around this circle on the top and the bottom is how long this rectangle is. Right, so this rectangle is essentially the circumference of the circle, which we find by doing 2 pi r, which in this case will be 10 pi inches, because the radius of the circle is 5 inches. So when we break apart a cylinder, we get 2 circles and a rectangle. And the sides of the rectangle, one side is just the height of the cylinder, the other side is the circumference of the circle. So then after that, you can complete that. You just find the area of this circle, which you know how to do, multiply that by 2 because there are 2 of them, and then you find the area of this rectangle and you add those results together. Finally, the last shape I want to talk about as far as surface area is concerned is a cone. Cone is where you have a circular base. We have a circular base and then a side face that meets up at a point, like so. And generally the dimensions of a cone are the radius of this circle, which we'll call 7 centimeters, and the height of the cone, which goes from the center of the circle all the way up to the tip of the pyramid. We'll call that h. And then finally, this dimension here, which is along the slanted side of the pyramid, that's actually called the slant height. And we usually use the letter L for that. And so when you break this apart into its surfaces, we again have a circular base, so that part makes sense. We break this apart into a circle with the same radius as the one we see in the picture, so 7 centimeters. And we know that the area of that circle is pi r squared. That's nothing new. The other shape that comes out of this figure, which is this weird top of the cone shape, when you unwrap that, or if you somehow cut along that shape to the tip and open it up, it actually looks like this. It looks like kind of like a triangle. But then it has a curved side. So kind of like a triangle with a curved side. Oops. So that's the type of shape we get. And the if we're cutting along this side here to make that happen, that means we're cutting along this length, the slant height, which means this triangle looking thing has this dimension of L. The slant height is on that side. And I'm just going to give you the area formula for that because it's not one of the shapes that we've seen before. The area for this is pi times the radius times L. Radius being the radius of this other circle that's in the figure. All right, so we do pi times r times the slant height. So looking at this picture here, we would do L times 7 times pi to get the area of this weird shape. And these are the only two surfaces we get when we break this cone apart. So our total surface area, if I wanted to write a surface area formula without doing this breaking apart stuff, then I would just add these two formulas together, one for each of the two shapes that we see. So it'll be pi r squared plus pi r L. Right, that's directly the surface area formula for a cone. Right, I'm not giving you formulas for a prism or a cylinder or anything. You can do all of those by breaking it apart into its faces and then finding the areas of the faces and then adding them together. But for this one, since we don't have this is not one of the shapes that we've talked about how to find area of, there isn't a formula for it. And so we get a kind of a formula for the surface area of a cone. Right, so if you see a cone, you can use that surface area formula to find its surface area. This is a cylinder, which is in fact a prism, the previous example. And then this, if you want to write down the name for the first example we did, is called a square prism. Right, it might be helpful to know some of these names. And I just realized I lied. There's another shape that we need to talk about and give a formula for, because we can't like unwrap it into its different shapes, and that's because there's not much to unwrap, and it is a sphere. So the last figure. Question is, do we keep them simplified or do we completely finish out the equation? If you're asking about the pi, then you can leave answers in terms of pi. I don't know what else you would be asking about. If you're asking about, are you supposed to do these separately and then add them together to get this answer, then yes. You're supposed to get it down to this answer. If you're talking about the pi stuff, then I would leave it in terms of pi. And if you can add things together, then add them together. But if one has a pi and the other one doesn't have a pi, then you leave it as is. Last thing we need to talk about is a cylinder. So we'll draw a cylinder here, and from the center of the cylinder to any point on the cylinder, on the surface, is going to be called the radius r. A cylinder only has one dimension to it. Well, it's a three-dimensional shape, but there's only one dimension that we have to define. It has a distance of r in all three dimensions, essentially. And a sphere has a surface area formula that is 4 pi r squared. So we have a nice little formula for the surface area of a sphere. Okay, that pretty much covers the surface area portion. Are there any questions on surface area? Okay, let us talk about volume next. We're going to break up our volumes into three separate categories. We're going to talk about prisms as one kind of way to find volume of prisms. And then a different kind of shape we'll talk about is pyramids and cones, which kind of go together. And then we'll talk about sphere. So, volume of a prism. And I should define what a prism is. A prism is essentially any three-dimensional figure that has two identical bases connected using rectangles. Now, those bases can be anything from squares to rectangles to triangles to pentagons to circles, even semicircles. Those are all going to be prisms. So when we talk about something like you don't need to draw this, but if I have like a semicircle base and then a straight vertical and then another semicircle up here. Oops, that one could have been solid. If I have something that looks like this, that's what we're going to call a prism as well. So it's two identical bases. There's this base and this base, and then they're connected by rectangles. This is one rectangle here, and then the other rectangle is the one that curves around the back of the figure. All right, so any shape that has two identical bases connected with rectangles, we're going to call a prism. And how we're going to find the volume of said prism is we're going to find the area of the base, and we're going to multiply by the height of the prism. And for the height of the prism, that's essentially going to be the distance between bases. Okay, what do I mean by that? Let me do an example here where we have, let me copy this example from the first page. So go ahead and draw a new rectangular prism. We'll change around the dimensions a little bit so we have something more interesting. we'll call this height 7. We'll make this depth 4 and the width 3, so that we actually have a rectangle on the bottom, a rectangle on top, and then a bunch of rectangles around connecting those two bases. All right, so I'm going to start by identifying the base of this prism. Now, there are multiple ways to identify a base here because we have so many rectangles to choose from, and there are so many identical ones. For example, the natural way to do it, the intuitive way, is to say that this rectangle on the bottom, that's on the ground, and the rectangle at the top are identical to each other, so I can call those bases. And then, in fact, they are connected by rectangles, right? All of these faces that are connecting them are rectangles. On the other hand, we could also say that this front rectangle in the front of this shape and the back rectangle are also identical, right? They are 7 by 3 rectangles, and those two rectangles could also be the bases. And then the faces that are connecting them would be these rectangles here, right? Or we could choose this right side rectangle and this left side rectangle to be the bases as well. So in the case of a rectangular prism where you have a bunch of rectangles on top and bottom and all of the sides, it doesn't matter which side you choose to be a base. You just have to make sure you keep track of what you choose as your base, because the height depends on what you chose as your bases. Remember, the height is the distance between the bases. So if I choose this top and bottom to be my bases, then the distance between them will be the 7 inches. Right? That's how far those two bases are apart. On the other hand, if I chose this right side and left side rectangles to be my bases, then the distance between them is this 3 inches. Right? That's how far apart they are. So we're free to choose whichever one we want as the base, but just keep track of it. I'm actually going to draw the base that I'm choosing here. I'm going to choose the 3 by 4 rectangle to be my base, the bottom one here. And I'll write the dimensions here, 4 inches by 3 inches. And my area for this will be 3 times 4, which is equal to 12 square inches. And then as far as volume is concerned, we're going to take that area of the base and we're going to multiply it by the distance between the bases. So we're going to take that 12, we're going to multiply it by the distance between the bases, and that, again, if we choose this bottom and this top as our bases, which we have here, then the distance between those is the height of this prism, which is 7. So it'll be 12 times 7, which is equal to 84 square inches. So that's what we end up with as our volume.
Wouldn't it end up actually being cubed?
Oh, I'm sorry. Yes. It should be cubed. If we're doing volume, we're multiplying essentially 3 dimensions together. We multiplied the length of the length and the width of the base, and then finally we multiplied by a 3rd dimension, so we get cubic inches. Thank you. In case it doesn't make sense to you why we do this, why we find the area of the base and multiply by the height, you can think of it as finding this area of the base is kind of like finding out how much stuff can fit inside of this 2-dimensional rectangle, right? And then if I were to stack a bunch of those rectangles together, I can form this this rectangular prism. By doing so, I can stack a bunch of these rectangles on top of each other, going up all the way to the top here. And how much of those rectangles we're going to stack on top of each other is essentially 7 inches worth. So we take the area of this base and we multiply by 7 because we're stacking 7 inches of those rectangles on top of each other. Right? So we stack a bunch of these on top of each other, and that's why we multiply the area of the base times the height of the prism. Okay. Cool. That's how we do volume of a prism. So let's move on to volumes of pyramids and cones. So for volume of pyramid / cone, we're essentially going to do the same thing, but because there is no second base, we're actually not stacking the same rectangle essentially on top of each other a bunch of times. There is a factor that we multiply by, and it turns out that 1/3 of the same formula for volume works for pyramids and cones. So 1/3 of the area of the base times the height of pyramid / cone, whichever one we're working with. Right, in this case, we're talking about things like we might have a rectangular pyramid we might have something like that, or we might have a cone where we have a circular base that meets at a point at the top. Right, in either case, we have a obvious base, whether it's a rectangle or a circle, or it could be a triangular base as well, or it could be a pentagon base, whatever the base is. The height, though, is measured from the center of the base up to the tip of the pyramid. So that's what we call the height of a cone or a pyramid. Okay, so that's what this height is here. So this is h. As for the volume of a sphere, if I have a sphere, again with the radius, right, from the center to any point on the sphere is the only dimension we have in there. So then there's just a formula for this. The volume of a sphere is 4/3 pi r cubed. Right, so we just have a formula for that. We use that formula to find the volume of a sphere. Are there any questions on anything?